Okay, last conic section and last section in pre-calc, and then we're going to start calculus. So remember, conic section is really, I have two cones on top of each other, and if I slice this thing straight down, I end up with a hyperbola, okay? So which is like two parabola-esque shapes that are facing away from each other. All right, so the only part of this graph that is actually a hyperbola is this arm and this arm make the hyperbola, and then on a vertically adjusted hyperbola, we have these two lines. So we don't really say the major axis for a hyperbola, we say the transverse axis because we don't know. Sometimes the transverse axis is shorter than the conjugate axis. Okay, so the direction it faces, this, in this case, the x would be the transverse, and the y-axis would be the conjugate axis. Okay, so since the parabola is facing vertically, this would be the transverse axis, and the horizontal would be the conjugate. Okay. Next, the distance from the center, so here's my center, to the point on the parabola, which we call the vertex, here's another, a vertex, is a distance of a. Okay. Again, point center to the vertex is a distance of a. Okay, so that doesn't change. And then the distance from here to the top of this box, which I'll tell you all about, is the distance b. So on the how you count on the conjugate axis is the distance b, okay, in both directions. Okay, these right here, these dotted lines, these are asymptotes. And this would also be an asymptote. And this one as well, and this one, okay? Lastly, we have the focus points. So focus, focus. Notice that they are in the dish of the parabola, or sorry, hyperbola. Okay. Here are our equations. So this is the equation of a standard form hyperbola. I want you to take note that the a squared and the b squared, they stay under the first and the second term, so they don't switch. This is a little bit different than ellipses. Okay. Another difference in ellipses is that the focus point, you use the equation a squared plus b squared. Okay. So how can you tell the equation of a hyperbola? So look at these two equations. Notice that on the right, these two perfect squares are separated by a minus sign. So what kind of shape do I have? We have a hyperbola. And this equation is separated by a positive sign. So we have an ellipse. Both my x and y's are squared, and then my equations are separated by different signs. That will come up on the test. All right, let's find our key features, and then we're going to graph this right now. Okay, so looking at this equation, since the y is squared, I already know that the transverse axis is vertical. I know that my center, h comma k, is 0, 0. I know my a squared, remember it doesn't change, a squared is the first and b squared is the second. A squared is equal to 9, so a is equal to 3. And b squared is equal to 16, so b is equal to 4. Okay, so I'm going to go ahead and get my c squared since I know my a and my b. It's 9 plus 16 is 25. So I think C is equal to 5. And then let's get some sketching going on and we'll go from there. Okay. So my center is at 0, 0. The next thing you're going to do is build your asymptote equations. So the slope of the asymptotes for a vertically oriented hyperbola. So the asymptotes, the equation is y is equal to a over b. Actually, it's plus or minus a over b times x minus h plus k. Okay, so for us, that's going to be 3 plus or minus 3 over 4 x, because my h and k are 0. So point slope form, I'm going to start at 0, and then I'm going to go up 3, and to the right 4. So a slope of 3, 4. And then also, so one asymptote is going to be through this point. We can also go down 3, 1, 2, 3, to the left 4. Okay, so that's one asymptote. And then the negative asymptote, I'm just going to count again, 1, 2, 3, but to the left 4, 1, 2, 3, 4. My slope is negative 3 over 4. And my asymptote goes through these points. Okay. What I do is I go ahead and draw in a box so that I know that I connect the asymptotes through the corners of the box. And then I can also see that on my transverse axis, I count up 1, 2, 3 units. So my hyperbola's vertex, this should be my A value, is 3. Okay. And then the rest of the hyperbola, we just sketch it in. We get closer and closer to the asymptotes, making a curved line. Okay. The last thing we need to do is actually get the values of these vertices. So the vertices, I'm starting at 0, 0, and I added and I subtracted 3 units. So my vertices are at 0 plus or minus 3. Okay. My foci, 0. I started at 0, 0. My foci distance is 5, so I'm going to count up from the vertex, from the center, 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. So I'm adding and subtracting 5 to the y values, which gives me 0 plus or minus 5. Okay, and then we have our asymptote equation as well. And that's it. Oops, I have that, and my graph. Let me see my center. Oh, my center. Okay. Okay, last one. My center, h comma k, is 1 comma negative 2. My a, that's a squared, so a is equal to 2, and b is equal to 1. C squared is equal to 4 plus 1. So C is equal to the square root of 5. All right, time to go ahead and start graphing. Okay, my center is at 1 comma negative 2. All right, and then from there, my x squared is first, it's positive, so this is horizontal. Okay. So I'm going to count out 2 units to the right, 1, 2, and 2 units to the left, 1, 2. Okay, and then that's where my vertices are, and I'm going to go ahead and count up 1 and down 1 from the center for my b value. Now I'm going to make my box, my rectangle. And the asymptotes go through the corners of these boxes. This is a rise of up 1 over 1, 2, and then up 1 to the left 1, 2. So a slope of 1/2 and negative 1/2. Asymptotes we draw in with dotted lines because they are not technically a part of my graph. Okay, so the next thing we're going to do is I'm going to, since the graph is horizontal, my vertex is going to be horizontal on the box. Okay, I'm going to sketch in the lines, 1 and 2. Oh, I totally touched that asymptote. Okay, my C value is √5, which is a little bit more than 2, so about 2.24, I think. So I'm going to count 1, 2.24, the focus, and 2, the focus. And that is it for the graph. So I have a center at 1, 2. I have foci I started at 1 and 1 comma negative 2, and I added and subtracted my C value, which is √5. So those are the points for my foci. My asymptote equation is y is equal to plus or minus a over b. Sorry, b over a because it's vertical. B over a times x minus h plus k. So this is point slope form, plus or minus 1 over 2 times x minus 1, this is my h and my k, minus 2. And that's the equation for my asymptotes. Okay. Oh, my vertices. Okay, I started at 1 comma negative 2, and I added 1, 2 units horizontally, so I'm adding plus or minusing 2, which gives me 1 plus 2 is 3 comma negative 2, and 1 minus 2 gives me negative 1 comma 2. So those are my vertices. Okay, just one thing before we finish up. So if my equation is in general form, how can I tell what the difference is, what kind of conics I have here? So for a circle, if I have an ax, so both squared variables are represented. Variables with same coefficient. Okay. Parabola, only one variable is squared. Okay. An ellipse, both variables are squared with different coefficients. So both variables are squared with different coefficients with the same sign. So both positive or both negative. Okay. And then lastly, we have the hyperbola where both variables are squared with different coefficients with different signs. Okay, so if I look up here, I can see which one goes with which. The first is a parabola because I only have an x squared represented. Okay, the next, I can see that I have an x squared and a y squared. They have different signs, different coefficients. That's a hyperbola. Next, I have x squared and y squared represented. The sign is positive, but I have different coefficients, so that is an ellipse. And lastly, I have, well, I hope that this is a circle, but let's look. Both x's and y's are squared with the same coefficient, so that's a circle. So before you start completing the square, you should kind of know which conic section you have.